In lab exercise 6, we talk about you have two options to reduce the runtime. And also in the Monday recorded video at the end, we talk about the algorithm, how to do the option 1. So you can see here, we will have our section for turns. That's a new struct we create. So then we will check the turn first, then we check the section. So if the turn exists, then we need to continue to check if the section exists. If the section exists, that's a duplicate. So then we continue and back to the while loop at the beginning. Otherwise, if the turn is not exist, we need to add a new turn in the section. So here in the discussion for your lab exercise 6, I asked you guys to complete these two code blocks. So then we see here, did you make that correct? Or we can review, maybe you do differently, but that's also correct. It doesn't matter, because the most important thing is, I just want you to guys to think about how to approach to reduce the downtime. So here the option we provide you may not be the only solution, but just according to the flow chart I show you here, so then I will give you the simple code, how we will do that. So then we go back to see our simple code. So before we start doing the duplicate check, so right here I have the static array we will use. Because like we talked about in the video, we have the section for turn struct now. So this section for turn object, they will create the object, have the turn as the name. Then we have the number of sections seen for the index for the scene section array. So I have to add this one. So then you can see here, our subject code didn't change at all. So the only thing I change is we make an already seen static array. So here, because already seen static array, the data type is section for turn. Oh yeah, so here I type wrong. Okay, so that's section for turn. So that's the section for turn is the data type. So then we know, remember we say in the past 20 years, actually we may only have 60 turns. So we make the capacities 100 will be enough. So then let's see here how we will do our duplicate check. So then, yeah, other than that, everything the same. Just one index we changed. So now because our index is for the already seen array, so then we call number of turns. So just know so far how many turns we have. So then you can see, right, we finish, we open the file, we do the parsing. So after the parsing, let's do the duplicate check. So you can see here, we have to continue for the subject code, but that's after the duplicate check. So here I leave this code block. On this space, we do the duplicate check. So the first thing, that's check the turn. So right, now to check the turn, we need to check the turn for this already seen array, right? Right, so the same thing, we always need to have a for loop. So then the same thing, you can have the index I star equal to 0. So this index we may need later. So then in your for loop, okay, so for I equal to 0. So then now, because we want to check already seen array, right? So already seen array, actually here, we don't really need using the capacity. So what we need to do is we were using the number of turn as our index for the already seen. And also that's for the boundary. So far, how many turn we have for the already seen array. So then you can see here, our I boundary is number of turn. So then right, I plus plus. So what should we compare? Right, because now we want to check the turns, right? So right, so here for our already seen array, we will do in the for loop, in this for loop, we will check. So for each object, on each I index, so then I need to check the turn the same or not. So right, so here the term we will compare is the term we parsing from the each line. But now here I need to compare what? Right, our already seen is a section for terms array. So each index actually is this object. So we need to check this object, the term value equal to our term or not. So that's why here, right? We need to using the index. But this index, if we have here, they represent the object. So that's why we need to check this term equal to the term we have or not. So that's we will compare to check the term. So did you remember we check the term? If the term exists, what should we do? Right, we should, if we have checked if the term is equal to the term we have, right? So right, we will break from this for loop. So if we break from the for loop that means the term found. So then right, then we need to continue to check until after the term is found. Then we need to continue to check the section from the find terms. So that's the check the term. So of course you see here, you need to have a for loop. So we check the term. If the term find, we break from the for loop. But then actually, when you break from the for loop or the for loop finish until we can get the line 81, actually we have two conditions, right? So the two condition is which one? So the two condition actually came from here, right? When you check the term in the for loop, you have two situations. Yeah, if the term find true, that means we break from the for loop. Then we continue check the section. But if we check the term, we never find the term, then we leave the for loop, right? So we leave the for loop, that means the for loop reach to the end. Right, so that's why here in our code, very similar than before, right? So now here, actually, if the term not found, the index I actually will equal to the number of terms, right? Good, so that's why we have two situations. We need to check. Actually, when we finish the for loop, our I has two conditions, okay? One condition is they finish the I equal to, so if I equal to the number of terms, right? So that means we are not found. So if we are not found, what should we do? Right, we need to add the new term, right? So remember here, if they're not found, we need to add the new term in the section. How should we add the new term in section? Right, so actually here, when we add new term in the section, we just need to create a new object. So this object is our section for term. So this number, the section for terms, actually we have the terms and we have our number of sections seen. So then because now you know your term is the current term you have. So then you have your number of sections seen. And also you need to have your seen section add to the array as well. So that's why here, since the array insertion, we need to do separately because we don't really have initializer. Yeah, actually we do have initializer, but our dynamic array didn't support for that. So that's why now here, let's create an object. So this new object is what? Is the new section for term. So we were using this already seen. So then here, either I or number of term doesn't matter. If you want to have less typing, so you do the I, but actually here the I equal to the number of term. So then here, this value, we will give them a new object. So then this new object, the first value term is the term we have now. So then already seen section so far is 0. Okay, so then remember the constructor. When you have your constructor, your struct, then you have the struct value you want to initialize object. We're just using the braces. So then they will follow the value they have. So that's why you can see here the value we have is the term and number of sections seen so far. So far actually we put the 0 first. Then we see after we add this one, we do the 1. Or that's up to you. You can either put here is 1. Okay, so then you just add the first one is a 0. So either one you can do. Okay, so now you see your new term of section, new term for the section being created. So the location is at the number of term. But here you only give them the term value and so far you have one section. But you didn't give them a section yet. So that's why we need to assign the section, right? So that's why the same thing here, when you assign, you already seen I. So that's the object. Earlier we assigned that object. But now here we need to do is we need to assign that array. So then you have your already seen struct is section for the term. So then actually we need to add the section to this seen section number array. So that's why here that one is part of your subject, right? So that's why here your object, then you need to do the dot seen section number of sections seen. Yeah, seen section number is the array. So that's why you see here you have the first level array is for the term for the section. So then now here you do the dot, you can go to the second dimension. So then you have your seen section number, that's the array name. So then here, because we only add the new section, the first one. So this section actually will be in this term, the first one exists. So then they equal to the section. So this section you assign is came from your parsing. So that's because we check the term first. Then if the term exists, we break. But no matter what, eventually we finish the for loop. So after we finish for loop, we need to see. If the term not found, that means they finish the for loop with the I hit the boundary. So that's why I equal to number of term. So then you see we assign that object equal to that location. So then in that location, we have the section array. So then we assign the section number to the first location. Then don't forget, right? So after you add that object, right? So now your number of turn increment by 1. So this one is, we say we find the turn. So then you actually can continue because one thing is here, if the I equal to number of turn, that means the turn not found, right? So then actually continue. The else actually will be what? The turn is found. So the turn is found. What we need to do is we just need to check the section. So that's why you need to using the I object again. But one thing is this one we need to have another for loop. We need to using this object, the seen section array, to do the for loop to find our section. So turn is find. Then find the section. Okay, so actually this one is our number 2. The turn is found, so then that we need to continue to check the turn for the found section, found turn. Okay, so that's why actually that's our number 2. So that's why you see here actually is another for loop. So this one, let's use the J. So J start from 0. So J less than what? Then J plus plus. You need to think about the condition. So then we need to check is this array.